Okay, this is the first video for 8.3 for pre-cal. It's due Monday the 6th. So you've got a full week to get it done. So I'm going to do half of it today and then and post it, and then the other half I'll probably do Wednesday. Anyway, it's not due till the 6th. So I'm going to do half of it today. It'll get you through half of what's on the computer. I think there's 20 problems on the computer. This should get you through the first 10 or 12 at least, and then I'll come back with another video on the rest of it. So what you're doing here is we're looking at complex numbers again. Remember, complex numbers are a plus bi, where a is the real part and b is the imaginary part. So we're looking at complex numbers, and we're looking at and writing them in standard form, which we've already seen, and we're still going to look at, and then writing them in trig form, which trig form has to be written in radians. A trig form would look something like 3 times cosine pi over 4 plus I sine pi over 4. So our angles are for the most part going to be written in radians, sometimes in degrees, very seldom, most of the time in radians, and then with this cosine and this I sine. So this is what trig form looks like. So we're going to have to go from standard form, this is called standard form, a plus bi is your standard form. We're going to have to go back and forth. We're going to have to go back and forth from standard form to trig form, from trig form to standard form. So before we go any further, there's just some things I want us to write down so we can have quick reference to them and not have to figure it out every single time, okay? So that's what we're going to be doing, but we need to backtrack a little bit and just make sure we know some things quickly. So like I said, it doesn't take us forever to do these problems. So 45 degrees is pi over 4. Now 45 degrees is a common reference angle. In fact, that's going to be a reference angle you use a lot. So anything with a denominator of 4 has a reference angle of 45, has a reference angle of pi over 4. Why is it important? Because we're going to need sine, cosine, and tangent of this reference angle, okay? So remember, sine of 45 is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. And tangent of 45 is 1, because remember, tangent is sine over cosine. It's sine over cosine. Okay, so we're going to need to remember that 45 is pi over 4. And any angle, any radian angle that we see with a 4 in the denominator is going to have a reference angle. So its sign is going to be either positive, negative, square root of 2 over 2, cosine, positive, negative, square root of 2 over 2, tangent, positive, negative, 1, depending on which quadrant it's in. So we've got to remember all that stuff as well. Okay, so that's the 45 degree angle. Then another common reference angle will be the 60 degree angle, and we want 60 degrees in radians. So 60 degrees is pi over 3 radians. That's what 60 degrees is. And again, so anything ending in a 3, anything with a denominator of 3 in radians has a reference angle of 60. Now, why do we need to know that? Because we need to remember the sine of 60. We need to know that pi over 3 is 60. Anything with a denominator of 3 is going to have a reference angle of 60. And remember that the sine of 60 is the square root of 3 over 2. That the cosine of 60 is 1/2. And that the tangent of 60 is square root of 3. Because it's the top of the sine over the top of the cosine. Square root of 3 over 1, which is the square root of 3. So let me just check my math right quick to make sure, okay? Just to make sure. Okay, so that's 60 degrees. So common reference angle 45 or pi over 4, common reference angle 60 or pi over 3. Got sine, cosine, and tangent of all of those. Now we need the other common reference angle, which is 30 degrees. 30 degrees is pi over 6 in radians. The sine of 30 is the cosine of 60, so the sine of 30 is 1/2. You can check that in your calculator if you want to, but it's 1/2. The cosine of 30 is the same as the sine of 60, so it's a square root of 3 over 2. And then the tangent of 30 is the reciprocal of the tangent of 60, so it would be square root of 3 over 3. It would wind up being the square root of 3 over 3, because you'd have reciprocal 1 over the square root of 3, and you have to fix that. Multiply top and bottom by the square root of 3 over 3, okay? I mean by the square root of 3, top and bottom, which gives you the square root of 3 over 3. So there's my 3 common reference angles that we're going to have to use, and sine, cosine, and tangent of all of those reference angles, okay? Of all the reference angles. Now, there's other angles that are special angles that we need to know about. We need to know that 90 is pi over 2, and its sine of pi over 2, or sine of 90, is 1, a positive 1. Its cosine is 0. Its tangent is undefined. Tangent of 90 is undefined. So that's another special reference angles that we need. Well, actually, they won't be they're not reference angles. They're just angles that you're going to see a lot. 270 is another one. That's 3 pi over 2. Its sine of 270 is negative 1. Its cosine of 270, or the cosine of 270, is 0. And then the tangent of 270 is also undefined, because, again, it's sine over cosine. If I'm dividing a negative 1 by 0, I get undefined. I can't do that. Then let's see, 180. 180 is another special one. 180 is pi. And its sine, the sine of 180 is 0. The cosine of 180 is negative 1. And the tangent of 180 is 0, because it's sine over cosine. Sine divided by cosine. So the tangent of 180 is 0. Then you've got a 0 degrees, and it's 0 radians. The sine of 0 is 0. The sine of 0 is positive 1. Sorry. Cosine of 0 is positive 1. Tangent of 0 is 0. So those are special angles. These are special angles that we're going to use. And then these are reference angles that we're going to use. Those right there. Okay. So let's see. I've talked about complex form, standard form. Okay, so the first thing we're going to have to do is take a complex number like 4 plus 3i. We're going to graph it, and we're going to find its absolute value. So we're going to graph it first. You're going to be asked to graph it first, and then find the absolute value. To graph it, it's very easy. 4 is your x, and 3 is your y. This is your I, and this is your x. So your real part, or your real part, that's your real axis. This is your imaginary axis. So 4 plus 3, I would go right 4, up 3. Right 4, up 3. Right there. That's how you graph it. Now, then you're going to have to find what's called the absolute value. The absolute value is just where you take the square root of a squared plus b squared. Very easy. That's all you do. Take the square root of a squared plus b squared. So 4 squared plus 3 squared, you want the square root of that. So that's 16 and 9, so that's the square root of 25. So your absolute value is 5. So there's your absolute value, and that's the way it's graphed. Now, just FYI, you can always draw a right triangle in. This is 4, this is 3. It's a 3, 4, 5 pi tri. Because this absolute value is always looking for the hypotenuse of that right triangle that you can draw. Okay? But just remember, graphing it's easy, just graphing a regular point, and then that's how you find absolute value. So let's see, let's talk about another one. I want to graph I, and I want to find the absolute value of I. So graphing I, well, the real part, if this was written in a plus bi form, it'd be 0 plus I. So it's really just, and there's a 1 in front of the I, so it's really just up 1. It's right there on the I axis. To find the absolute value, again, it's the square root of a squared plus b squared, so it's the square root of 0 squared plus 1 squared, because there's a 1 in front of the I. So that would be the square root of 1, so it would just be 1. So your absolute value there is 1. There's the absolute value, and that's the way it's graphed. Then let's see, 4 minus I. So 4 minus I, if I were to graph this, this would be right 4 and down 1. Right 4 down 1, because that's an I. So right 4 down 1. There it is right there. Right 4 down 1. Then absolute value, to find the absolute value, is just a squared plus b squared. There's a negative 1. It's going to square it anyway, so it's just 4 squared plus 1 squared. So that would be the square root of 17. That's the absolute value. Graphed, absolute value. Let's see. This is 3. So that means it's 3 plus 0i if we wrote it in standard form, writing it in standard form. So it would just be right 3, right there. Square root of 3 squared plus 0 squared. So that'd be the square root of 9, which is 3. So absolute value is 3. So graphed, absolute value. Okay, I think that's enough of those. Now those were in standard form. Okay, and then sometimes you're going to be given the graph and you're going to be asked to write it in standard form and in trig notation. Okay, so standard form, easy, easy, easy. Standard form is at a plus bi. So you're just going to look at it and go, okay, and you'll be able to tell better on the computer what this is, but it's actually, this is a 2, this is a 4, this is a negative 2, this is a negative 4. So we're at right 3 down 3. So we're at right 3 down 3. So standard form would be 3 minus 3i. Okay, just like graphing a point, just like looking at a point on a coordinate grid and graphing it. So it's 3 minus 3i. That's your standard form. Now, to write it in trig notation, to write trig notation for this, you're going to have to find the absolute value first. So we want absolute value. So that's the square root of 3 squared plus 3 squared. Because remember, it's the square root of a squared plus b squared. I know there's a negative in front of it, but I would square it away anyway. So that's the square root of 18, which is 3 square roots of 2. You've got to make sure you simplify that, okay? Now what we've got to do, because, you know, I showed you at the very first how that trig notation is, that you've got this number outside, which is your absolute value, and then inside you've got cosine of an angle plus I sine of the angle. So now we have to find this angle here. We have to find this angle. So to find the angle measure, it's an inverse tangent of b over a. To find that angle, it's inverse tangent of b over a. So we need to know what that tangent is. So we use b over a. So inverse tangent of b over a. So 3 over 3. I know there's a negative there. It's okay. Don't worry about that right now. So it's the inverse tangent of 1. So you can type that in your calculator. You can look at, well, I erased them. You can look and see whose angle has a tangent of 1. It's actually 45 degrees. So that is your reference angle, or pi over 4. That's your reference angle, okay? Because remember, we want these in exact answers and use pi as needed. So with exact, when it says exact, you want radians. So you want this in radians, okay? So we got to find the angle measure. We had to do the inverse tangent of b over a, which here is 3 over 3. That means we want the inverse tangent of 1, which angle 45 is the angle that has a tangent of 1. So that's a pi over 4. Already talked about that. That's pi over 4. So that's your reference angle. Now, we're in the 4th quadrant. So my reference angle here is pi over 4. So I need to know how to get this angle right here. So this right here is either 360 or 2 pi. Or it's 0, but 0 doesn't help us any because we need to be in the 4th quadrant. So what we need to do is we need to do 2 pi minus pi over 4. So that means that would be 8 pi over 4, if I fix it and have the right denominator, minus pi over 4. So 7 pi over 4. So this is 7 pi over 4. So your angle in here is 7 pi over 4. So you've got your absolute value and you've got your angles. And I know that's a lot. I know that's a lot. That's why I'm breaking this up into 2 different parts. Okay? Because that's a lot to do. That's a lot to follow. But that's what you have to do to change from standard notation to trig notation, vice versa, that kind of stuff. So we're going to go both ways on these. Okay, so that's the first one. Let's do another one. Again, like I said, that's a lot, and so that's why we're doing this lesson in 2 different parts. So let's see. Okay, so we've got a graph again, and that's the point. Like I said, when you're looking on the computer, you're going to be able to tell better. That's actually 2 plus 2i, because it's right 2 up 2. So it's 2 plus 2i. Right 2 up 2. So there's your standard form, because it asks for standard form first. Standard form is that a plus bi form. So that's your standard form, okay? Now we want the trig notation. So the first thing we have to do for the trig notation is find that absolute value. The absolute value, remember, is the square root of a squared plus b squared. So we take our 2 and square it, and our 2 and square it. So that'd be the square root of 8, which is 2 square roots of 2. So there's your absolute value. That's the first thing. So we start out 2 square roots of 2, and then in parentheses we've got a cosine of an angle plus I sine of the angle, because that's trig notation for a complex number. That's why we have the I there, okay? Now I've got to find the angle measure. And I'm told exact. When I'm told exact, it must be, and it'll also tell you to use pi. So that's giving you a clue right there. It's got to be in radians. Okay? So what I do is I'm in the first quadrant, but I need to do the inverse tangent. I need to do the inverse tangent of b over a, which here would be inverse tangent of 2 over 2, which is the inverse tangent of 1 again, which is a 45-degree angle. I've already talked about it. It's nice. They gave it to us again that we have an inverse tangent of 1, so my angle is 45, which in radians, that's pi over 4. So because I'm in the first quadrant, that is my angle measure. I don't have to do anything to it. So as long as I'm in the first quadrant, my reference angle is the angle I put in here. So it'd be pi over 4 and pi over 4. So there's your trig notation. Standard notation you get from the graph. Trig notation, you do the absolute value, do the inverse tangent of b over a. It's gonna be one of these reference angles that we've already talked about. It's gonna be one of those, or it's gonna be 45, like this one, okay? To just get you in the groove of doing it. Okay, so let's try another one. Let's see. This one is at 4, right there. Okay, so that means standard notation is 0 plus 4i, which you would just put 4i, because remember, that's your imaginary, this is your real. So it would just be 4i, okay? Then if we want trig notation, we find the absolute value, a squared plus b squared, square root of a squared plus b squared, so 0 squared plus 4 squared. So that'd be the square root of 4 squared, which is just 4. So my absolute value is 4. So I start this by writing 4 cosine of an angle plus I sine of an angle, okay? So now I need to figure out what this angle is. Well, this isn't a reference angle. I don't have a reference angle because I'm on an axis. So straight up is 90, straight down is 270, straight left is 180, straight right is 0. Okay, so we're going straight up. So that means that's a 90-degree angle, which is pi over 2. So that's nice too. When it's straight up or straight down, very easy to find those angles. So pi over 2 is what you put in there. Okay, So that's given the graph and then finding the standard notation and the trig notation. Now you're going to be given one or the other and have to find, like you're going to be given standard notation, you need trig notation, or you're going to be given trig notation, you need to find standard notation. So we're going to do a few of those and then we're going to stop. I'll stop the video and go on. Okay, so 1 minus I. So you got to know, is this standard or trig notation? This is standard because it doesn't have the sine or cosine in it, okay? So we want trig notation. So I want the trig notation. So if I want the trig notation, that's where I do the square root of a squared plus b squared. So here it'd be the square root of 1 squared plus 1 squared, because that's a 1 there. I know it's a negative 1, but the negative 1 is square out anyway. So that'd be the square root of 2. So square root of 2 starts us off. Now we need the angle measure. Cosine, I sine, cosine. And that's always a plus. All you're having to do is fill in this, and then sometimes even on the computer, they'll give you this cosine and I sine thing on that. Okay, so they'll give you a blank for this, and they'll give you these blanks that you have to fill in. Okay, so now we just have to figure out, you know, our angle and where it is. So if it was right one down one, so I'm here. I'm in the 4th quadrant. Very important to know that. You've got to know that. That's why they ask you to graph them first, so you know how to graph them, and you get the right angle. You get in the right quadrant with your angle. So then let's see. I've already done the absolute value. Now I have got to do the inverse tangent. I've got to do the inverse tangent of b over a. So it's the inverse tangent of 1 over 1, because that's what it is, a 1 and a 1. So it's the inverse tangent of 1 again, which is 45 degrees, or pi over 4. What are they asking for here? Okay, they don't specify here, so you actually can put in degree measure. Actually, they do specify because they put a little degree mark. So some of these will be in degrees, so look at the computer. It'll give you spaces. If it has degree marks there, that means you want degrees. So I don't care that this is pi over 4. This is 415. So my reference angle is 415. So to find this angle, I have to do 360 minus 45, which is 315. I think I said something about 415. But there you go. There's your trig notation. That's your trig notation, given the standard notation. Okay, let's try negative 2 square roots of 2 plus 2 square roots of 2i. And we want it in trig notation, because that's standard notation. This is standard. We want trig notation. So first thing we want is the absolute value, which would be the square root of a squared plus b squared. So 2 square roots of 2 squared plus 2 square roots of 2 squared. Now 2 square roots of 2, guys, that's a square root of 8, if you don't remember it. And if you don't, let me show you how you can put this on your calculator, okay, so that you're not freaked out. But this turns out to be 8 plus 8. That's 16. So it should turn out to be 4. Okay? But let me show you how to put it on your calculator. So you want the square root. So put your square root in. And you want to make sure that you do 2 square roots of 2 all squared. So you're going to need to put that in parentheses, like I've done. Whoa, I didn't stop the... I wasn't watching what I was doing. Okay. So 2 square roots of 2, then get out from underneath that, do your parentheses and square it, okay? See how that looks? And then plus, do it again, 2 second square root, 2, get out from underneath that, and then square it. Get out from underneath the big radical, and enter. It's 4. But that's the way you can type it in your calculator, but it comes out to be 4. So 4, and then I've got, let's see, cosine, and this has a degree measure as well, a degree mark as well, so put it in degrees. So look for those markings, pay attention. If it says to use exact or pi, you know it's radians. If it doesn't say anything and it gives you the degree marks, it wants degrees, okay? So we've got to figure out where this is. We've got to figure out what quadrant this is in so I can get the right quadrant, okay? So that would be left, this is left, and this is up. So I go left, up, so I'm in the second quadrant, okay? Now I have to do the inverse tangent of b over a, which would be 2 square roots of 2 over 2 square roots of 2. Now I know that looks freaky, but guys, that's 1. That's the inverse tangent of 1, which is again 45 degrees. So my reference angle, which always comes from the x-axis, not ever the y-axis, always from the x-axis. So I would do 180 minus 45. And that gives me 135. So my angle here, 135 degrees, 135 degrees. Always come. You're always either, to find these angles, you're either doing 360 minus, you're doing 180 minus, or you're doing 180 plus. You are never using 90 or 270 ever. Ever, ever, ever. You're either doing 360 minus to get in the fourth quadrant, 180 plus to get in the third quadrant, or 180 minus to get in the second quadrant every single time to find these angles. Okay, let me do, let's see, negative 3i. Negative 3i. So negative 3i would be here because it's on the imaginary. That's where negative 3i is. That's the standard form. We want the trig notation, which this one's not going to be bad because I'm straight down. So my angle is 270. My angle is 270, or 3 pi over 2, depending on what I'm asked for. So I've already got my angle. All I need now is the absolute value, which is easy, a squared plus b squared. Well, if this is negative 3i, that's like 0 minus 3i. So 0 squared plus 3 squared, because again, I don't even bring the negative because I'm going to square it. It's going to go away anyway. So square root of 3 squared, which is just 3. So 3 cosine 270, if they want degrees, plus I sine 270, if they want degrees. Or 3 cosine 3 pi over 2, plus I sine 3 pi over 2. Depending on what you're asked for. This is exact. This is exact and using pi. That gives you radians. Otherwise, you want degrees and it looks like this. Okay? So that's nice. Let's see, another one. Square root of 3 plus I. Square root of 3 plus I. That's your standard notation. We want trig notation. So that's standard notation. So let's see, I want absolute value first. So it would be the square root of the square root of 3 squared plus 1 squared. Well, the square root of 3 squared is just 3 plus 1, so square root of 4, so 2. Gives me 2. Then figure out where I am. That's right, square root of 3 and up. So I'm in first quadrant, nice in first quadrant. I just need to figure out what that reference angle is. And it means I'd be doing the inverse tangent because it's not just straight up or down. You know, on the last one, it was straight down. That's 270. Like, we don't have to do any inverse tangent stuff. Here we do. It's inverse tangent of b over a. So it's inverse tangent of, 1 over square root of 3, which comes out to be the square root of 3 over 3. Which is, okay, I hope it don't make you dizzy, which is the 30-degree angle. Has a tangent of square root of 3 over 3. So this is 30 degrees. Now, if I want it in radians, it's pi over 6. So I've got my absolute value of 2 cosine pi over 6 plus I sine pi over 6. That's exact. If we wanted just degrees, it would look like this. Okay, so now let's go the other way. Now let's find the standard form, given the trig notation. Okay, so this is 20 cosine 225 plus I sine 225. Okay, so what we have to do is we have to find the cosine of 225 and we have to find the sine of 225. And you're going to have to keep everything exact. You cannot just type these on the calculator. You have to keep everything exact, and we have to type it in a plus bi form. We have to leave radicals if they're radicals, all that kind of stuff. So we need to figure out the cosine of 225. So 225 is in the third quadrant, because remember this is 90, this is 180, this is 270, and its reference angle is 45, because 180 plus 45 is 225. So its reference angle is 45, which means its sine is the square root of 2 over 2, and its cosine is the square root of 2 over 2. Sine, cosine, but because I'm in the third quadrant, sine and cosine are negative in the third quadrant, so they're both negative, okay? So that's the way we figure that. If anything ends in 5, guys, it's got a reference angle of 45, just FYI. 135, 315, 225, those are the ones you're going to see, okay? And since I'm in the third quadrant, we've talked about it before, sine and cosine are negative in the third quadrant. So then I do 20 times negative square root of 2 over 2 plus 20 with an I times negative square root of 2 over 2. So I would have 2 goes into 20, leaves a 10. So that's negative 10 square roots of 2 plus, well, it'd be minus really, minus 10i square roots of 2. Now sometimes the computer gets a little tacky on this and it'll want the I after the radical. Just make sure the I is not underneath the radical. So that's standard form. That's going from trig notation to standard form. Trig notation, standard form. Okay, let's try another one. Let's see, 8 cosine pi over 2 plus I sine pi over 2. So I want the cosine of pi over 2. Cosine of pi over 2, that's your 90-degree angle, okay? That's your 90-degree angle. And I gave you the cosine. The cosine of that is 0 plus the sine is 1. Okay, talked about that. Talked about the first of the video with the sine of 90 degrees and the cosine of 90 degrees. So then we do 8 times 0 plus 8i times 1. So we just wind up being 8i. Because the computer, don't think it'll let you put in 0 plus 8i. That's true standard form, but we usually just get rid of the 0 because 0 plus 8i is just 8i. Let's see, 3 cosine 30 plus I sine 30. 3 cosine 30 plus I sine 30. So sine and cosine of 30, we already did that. Cosine of 30 is square root of 3 over 2. Sine of 30 is 1/2. So I just replace them. I replace the sine of 30 with 1/2 with an I, and I replace the cosine of 30 with square root of 3 over 2. And they both have to be multiplied by 3. That 3 has to be distributed. So that would be 3 square roots of 3 over 2 plus 3 over 2i. That's the way that works. Okay, let's try another one. 10 times cosine 270 plus I sine 270. Now again, first of the video, I told you what the cosine of 270 was and what the sine of 270 was. Cosine of 270 is 0, so 10 times 0 plus 10i times negative 1, because the sine of 270 is negative 1. So 10 times 0 goes away, so negative 10i. That reduces, simplifies to negative 10i. Let's see, square root of 8 cosine pi over 4 plus I sine pi over 4. Okay, cosine pi over 4, that's the square root of 2 over 2 because that's your 45-degree angle and it's positive. square root of 2 over 2. Then we've got to distribute the square root of 8 to both of them. So square root of 8 times the square root of 2 is square root of 16 over 2. Well, that's 4 over 2, so that's 2. Same thing. Because square root of 8 times the square root of 2 is the square root of 16. I over 2. That's 4 over 2. I. So it's 2i. So 2 plus 2i. Sorry. I think I didn't move my phone. One more. Like this. 2 cosine pi over 2 plus I sine pi over 2. I know this is a lot, but you really need to get this. So I'm doing a lot of them. A cosine of pi over 2, that's the cosine of 90, which is 0. So 2 times 0. I may have done this one. And then 2 times I times the sine of pi over 2, which is 1. So it just winds up being 2i. Okay, then one other thing that I'm going to go over today is dividing and multiplying them. And then I'll be done. It's really easy. Okay, so all you do is divide 40 by 8, which is 5. For your angles, you subtract 32 minus 8, which is 24. And that's it. 5 cosine 24, I sine 24. You divide your numbers on you divide your absolute values. These are your absolute values, and you subtract your angle measures. That's all you do to it. Okay, then you're going to multiply these imaginary numbers, -4 plus 4i and -3 minus 3i. So I'm going to show you the multiplication first because it's just FOIL. We're going to FOIL it. But then on one of the questions, you're asked to change them into trig first and then multiply them. You don't have to. I mean, you have to on that one question because it asks for it. Like it leaves space for you to put them in the trig notation. But to multiply them, they don't have to be in trig notation. You can just FOIL it. So -4 times -3 is 12. -4 times -3i is plus 12i. 4i times -3 is -12i. And 4i times -3i is -12i squared. Then you just go from there. 12i, -12i cancels. I squared is -1. Don't forget about that. -12 and 1 is a positive 12. 12 plus 12, 24. Okay? So you can multiply them without them being in trig notation. But because it asks you to put them in trig notation, I just want to make sure that you remember. So if I've got -4 plus 4i, graphing that, it's left 1, up 1. So I'm in the second quadrant because it's left 1, up 1. I mean, it's left 4, up 4. Absolute value, square root of 4 squared plus 4 squared. So that's the square root of 8 and 8. No, 16 and 16. I knew I was messing up. So 4 squared is a 2. So that's your absolute value. And then if I want the angle measure, I have to do inverse tangent of 4 over 4, which again is 1, which again is the 45-degree angle. So if my reference angle is 45, so this is 135, because it's 180 minus 45. So I would have 4 squared is a 2, cosine 135 plus I sine 135. And on this one, there's one problem. On this one problem, you have to write them in trig notation first. So that's why I'm showing you this, okay? Then the other one you had was -3 minus 3i. So that's left 3, down 3. So that's in the third quadrant. So it'd be the square root of 3 squared plus 3 squared, which is 9 and 9, which is 18. So 3 squared is a 2 for your absolute value. Then you do your inverse tangent of 3 over 3, which again is 1, which again is 45. So that's a 45-degree angle, reference angle. 180 plus 45 is 225. So this would be 3 squared is a 2, cosine 225, plus I sine 225. And then I've already shown you how to multiply it. Sorry, there's a glare. That's what it is in trig notation. That's how they are in trig notation. That's what you're asked for first. If you're just asked to multiply them, just multiply them. If you're not asked to do trig notation, don't do trig notation, just multiply them. Okay? For example, if I have 1 minus I times 2 plus 2I, just FOIL it. 1 times 2 is 2, plus 2I, minus 2I, minus 2I squared. So those cancel. I get 2 plus 2, because that changes to a plus 2, so it's 4. So if you're just asked to multiply them, just multiply them. This is the last one. Negative 4 square roots of 3 minus 4I times negative 5I. It doesn't ask for, it says first to convert it into trigonometric form and then multiply, but it doesn't ask for the trigonometric form. So don't do it. Just do the multiplication. Just do, here it's just distributive property. So it would be 20, because negative 5 times negative 4 is 20, square roots of 3I, then plus 20I squared. The thing you need to remember, I squared is negative 1. That'll make that negative 20. So to write it in correct standard form, you've got to put that real part first. You've got to put the negative 20 first, then 20, then plus 20 square roots of 3I. Make sure the I is not underneath the radical. Okay, so that should get you through the first half of it. Probably 10 or 11 or 12, something like that. That should get you through that. And then I'll talk about the rest of it in the next video that I send out. And again, this isn't due until Monday the 6th.